Okay, last but not least, we have Gopal RAGHAVAN, Embedded AI Strategy at Microsoft, talking about challenges for large-scale deployment of TinyML devices.
Hey, thanks for inviting me here. I'm sort of the odd fish, I think, here, because I'm going to be talking about a different end of the story. So the first thing we should understand is there's been a lot of angst here. Why are there not enough deployments? How do we get more deployments? How do we all make money and so on? So to better understand that, this is sort of our view of the story. So if you look at it, all the silicon providers and all the device folks are right at that end. And I'm sorry, I didn't put, there are infinitely large number of people here, but I didn't put them in. And then you have the device builders who take this silicon and add sensors to it, add battery sources or power sources, add communications to it. And then it comes to system integrators who are actually domain experts and who deal with the end customer, and they pick a device which they believe, or multiple devices, which they believe is suitable for the particular application, right? And then they take this, they do machine learning on it, stick it all together, and that goes to the end customer. So if you look at it, there's only one person here who's actually paying. Everyone else is basically trying to get money from this person, right? So you need to figure out how are you going to, and of course, it goes without saying that as you go further to the left, the amount of money sort of drops. Okay? So why is this customer, now you have an end customer, now the question to think is, why do they want, and remember, they have to feed this entire chain, right? So there's a lot of money coming from them, and why are they paying this much money to make all of us happy? So for example, how many of you have done self-checkout in a store? Okay, so it turns out, if you go and do a web search, there's something called the banana trick, and there are many tricks by which what you can do is you can sort of substitute a lower cost scan for a higher cost device, higher cost grocery item and stuff. So for example, if people lose 1% due to this, they lose $50 billion, okay? Now you would think that if you had an ML solution that could address this problem and cut the 1% down to 0.5%, somebody might be willing to pay you a lot of money for that. But again, the problem is, who is the person who understands how a checkout stand looks and who puts devices there and puts cameras there? That is this person in between. Now it's possible that you could jump all these people and go here, but fundamentally this is the person who's giving you all the money. So we've been, I have a web link here, and there is stuff to where we went out, and actually Microsoft does this routinely, talks to a lot of customers and sees why or why not are they not deploying edge stuff. So it goes without saying, and I think most people who've been here for multiple years know that the IoT market and intelligent edge market predictions have been highly over-optimistic. I've been hearing billions of devices for the last 5 years. I built a startup thinking my billion was near, but got close to zero. So it's been wildly optimistic, and what can we do to improve that as a group, right? That's what we are all here for. So if you look at some of the reasons why people don't, the big companies have a problem deploying, some of the big reasons are it's too complex to scale and lack of infrastructure, right? And lack of technical knowledge. And so what can we do? We need to understand the entire ecosystem, and we need to architect solutions to address these problems which people have. So some of the tiny device challenges are, and I'll go into more details on each one of them, but fundamentally the tiny devices are a piece of the full edge AI device spectrum. No consumer of ours goes and says, I love tiny devices, I must deploy a tiny device, right? They go, I have a problem. If a tiny device solves it, great. If a big device solves it, great. So it's a spectrum. So while we are all sitting here on the tiny device end, the world doesn't revolve around us. So number 2, device lifecycle management, secure deployments, big problem. If you are going to have 1 million devices of yours out in the field and you don't have security, okay, nobody is going to put your device in the field because you all know what security threats are in the world right now. ML lifecycle management. So I've seen many presentations, people have tools and they say, look, it's so easy for the customer to use all that. But think about this. You have a data set, you have a model, you train it. Tomorrow, if you change your data set, you need to track your data sets, you need to track your models, you need to track your feature pipelines, you need to track all these things, right? So, and then you have things like concept data drift, which worsen the problem. And it's worth mentioning that especially with sensors and what we do, this is a very different beast from, say, things like, say, spam detection. Because in things like spam detection, the input is a very well-determined Unicode input, for example, that you take, and you can figure out what happens. Here, our input keeps on changing, right? I mean, you have a camera trying to count people here, and suddenly somebody decided to be eco-friendly and put a 1-watt light, LED light, and it's so dim you can't make out anything. How do you know that that happened, right? So you need to constantly monitor and feedback and do that. Otherwise, your stuff doesn't work well. And finally, not the least, is integration with business processes. The business folks who pay you the money want to look at something and go, hey, my loss dropped, my loss increased, things like that. And that is not done at the C level or at the edge. It's done in the cloud, and it's done with a lot of other integration, which you're not going to replace. So first item, which I said was, this is a whole spectrum of devices, right? So for example, we have stuff which is heavy, we have light edge, which is the MPU case, and we have tiny edge, which is MCU. And we have different set of software for all of those. So you can take your model, you can deploy it wherever you need to. That's point 1. Point 2 was devices. So to have certified devices allow rapid proof of concepts and subsequent large-scale deployments. About 70% of the projects, we believe, die at the POC stage. So if you get a POC, don't get too excited because you only have a 30% chance that it goes into production, right? So here is how a typical device looks in our world. The hardware is down here, SoC, secure memory, secure element. Then you have the device builder who takes that, adds all the peripheral sensors, adds all the software drivers, everything. What this allows the solution provider to do is, with their knowledge, like if you're in retail or you're in industrial or health and safety, they just build the top layer and everything else is already guaranteed. If you don't provide this person with a secure solution, they take an enormously long time to do that. Number 2, which I don't think most hardware people want to hear, is we want the devices to be not quite fungible, but somewhat fungible. So if a customer is deploying 1 million units, they want to make sure they don't buy all them, are not forced to buy all the million from one hardware provider. They would like multiple hardware providers to lower their risk and stuff. So you need to abstract away all the device stuff by the time you get to the solution provider, right? And then the whole MLOps cycle, I think Daniel brought this up quite well. So what we see is you have the business folks up front who have a business problem, and then the machine learning person comes up, collaborates, you build an app, and so you start out by first you do model reproducibility and then model validation. I think you've seen this path many times. But the main thing I want to point out is the deployment and monitoring. So I've seen so many people saying, OK, we can deploy, right? Think about how you're going to deploy 1 million devices, OK? These million devices, and they've all got to be secure devices to start off with, right? So you just can't take a device and, for example, you can't take your laptop and plug it in. Not going to work for 1 million devices. So how do you do that? And then finally, when the devices come back, you need to be monitoring that. And what we do is, of course, we connect it up to the cloud automatically. Additionally, we also get raw data from the sensor. So that's why it disturbs me when people start putting a lot of intelligence in the sensor, because we can't get raw data from the sensor to see if there's a problem. So what we do is we get raw data from the sensor, and every so often you retrain, and you can see if any sensor is not behaving properly or your model has a drift or whatever. And then we can specifically address, so let's say 10 sensors are in a very dark area. We can go and specifically tune the feature pipelines for those 10 sensors to make it brighter, so that overall your fleet of 1 million devices can still continue running and give you good results all the way across. So at scale, things really change, and you need to, there are really different set of problems that come about. And so I urge you all to think, when you deploy something, can I deploy 1 million of these, right? How do people update it? That's a big problem. You know, there's a software problem, something happens. How do you update that, right? So, and a shout out goes to the ARM folks here. One of the other things we like is the virtual hardware, because what we can do is we can deploy virtual hardware to see whether the deployment is going OK. The last thing you want to do is to upgrade all your 1 million devices with a new model and have it not work. You have a catastrophe. So there are standard ways of, deploying gradually and stuff. But the virtual hardware makes life much easier. And it also allows you to test problems with hardware, because it's easy to inject problems at this level as opposed to actually having hardware and trying to inject problems at the hardware level. And so the cloud is your friend. OK, that's the message. The cloud integration is really key to scale TinyML deployments. Business intelligence and decision making reside typically in the cloud, and that's what motivates people to do TinyML eventually. Device lifecycle management of billions of devices without the cloud and security, it's really hard to do. ML model development, performance monitoring, you train your model, the data is there, new data comes from the edge device, gets added, gets retrained. You can see if there's a problem. And then improving model accuracy. Everybody here has been fighting this battle. And one of the advantages we have having a cloud is, if you have a critical decision, like let's say you're detecting fire, you really don't want to call the fire department when your tiny device says there's a fire. Who knows what the accuracy is. So at that point, you send raw data up to the cloud, and there you run a big model, and you confirm that indeed it's a fire, and then you can, pull the fire alarm. So things like federated learning and decision making across fleets of devices all can happen once you have these devices connected to the cloud and the intelligence resides in the cloud. And we like to have a call of action. So one of the things I would like to urge you is, please try to support cloud integration in your eval kits. Don't just give us a board and a PC, because there's not much I can do with that. Number two, all your tool chains and model developers, please containerize your software when you give it to us for evaluation, because it's one of the biggest pains is somebody wants Python 2 and somebody wants Python 3, and I'm not going to make virtual environments for each one of you and try to evaluate your device. It's just too much pain, right? So containerize it, and you'll get a much better chance of people playing with it. And it makes your life easy too. You don't have to do a Windows version and a Mac version and a Linux version. And so other than that, we have low-code, no-code experiences. I won't get into all that. And the other thing also is please invest in standardized comparison of performance metrics like ML Commons. So when you say, I have the lowest energy, please give us something that we can compare on a standard. Otherwise, you ran something with a funny model and you showed me the best energy. I have no idea what that model is. So I'm less inclined. If you show me a comparison with ML Commons, I'm more likely to believe you. So with that, I think I'm done.
And we are very thankful for our sponsors. The premier sponsor this year is Edge and Pulse. And then executive sponsors are ARM, DeepLight, Qualcomm, and Syntiant. Platinum sponsor, Analog Devices, BrainChip, Infineon, Clickertech, Latent AI, NXP, Reality AI, Renaissance, Sony Semiconductor, and Synaptics. Really very diverse company, great companies who are really driving TinyML forward. And gold sponsors for the Hub, Micro AI, Prophecy, Seed Studio, SenseML, ST Microelectronics, SynSense, XMOS. And we have a list of civil sponsors, Avion Devices, Aspinity, Seva, EMSA, Greenwave Technologies, Grovity, Hymix, HOTG, Imagimob, Itemis, Lattice, Nota, OmniML, PixArt, Plumerai, Kixo, Rachner, Rixen, SAP, StreamAnalyze, Texil, and Google. So we are very thankful for their support and, more importantly, for them being part of this community and driving it forward.